and then I made a z-score and so forth. This picture was individuals. So how spread out is every individual from every other, from the mean of those individuals, right? This question is about groups. The spread changes when I'm talking about groups, doesn't it? That's exactly the whole damn thing with the alternate universe Florida. That was what all that was about. So again, like I said earlier, the worst part about math is when do I do that shit you just talked about, Jeff? Well, when do you do this? Take a sample, ask about the sample mean. I can't use a spread of individuals. I have to use a spread for groups. So, watch what happens. What's the very first thing I do here? And then normally I would draw the picture, make a z-score, but what's the very first thing I do? Change this shit. That's wrong. For my problem, that's wrong. Because this is for individuals. So how do I change it? Yeah, take it, divide by square root of 39. It's like 0.62. Total guess. 0.67. 0.67? Shit, I should have learned that. So 0.67. What was it? 6709. So 71. Okay. No?
No, I got 6693.
6693. Ooh, I like dissension. Kick ass. Let's see. Yeah, I get 6709.
I got the wrong number.
That's okay. Don't worry. It's all good.
4.18 will do that.
Huh?
4.18 instead of 4.19.
Oh shit, that'll do it. Everybody with me so far? At all? Anybody even with me a little bit? No? Please, the idea is weird. This is true. But the fact that the spread changes, I mean, that should make a little bit of intuitive sense. It's much less likely that a group is far away from the average than one person. One person can be 7 foot tall. That's still kind of like, whoa, 7 foot tall, whoa. A group of 20 randomly selected people have an average of 7 feet? Oh, holy shit. Holy shit. Right? It's like, what the hell? If I go to some island and I take a group of 20 people randomly selected, their average height is more than 7 feet, what are they eating? What's going on here? Is the gravity less in this area somehow? What is, oh, you know.
They got some GMO food.
Huh?
They got
GMO food? Yeah. Or maybe not GMO food, I don't know. Okay, maybe. Or they just do this thing where they get stretched out at night. I don't know. Something happens. Anyway, all right. Maybe. So the fact that groups, when I graph groups, they will have a skinnier distribution because it's much less likely a group is going to be far away. That is exactly what this formula says. The spread gets smaller for groups. So again, what have I done so far in this problem? One thing. This is the new thing. Now what do? Draw the picture. What goes in the middle? The mean, 29.3. I want less than 28. So I want this area, right? Every other step is the same now. In fact, every step is exactly the same. I just don't make a z-score based on this, because that's the wrong spread. I make a z-score based on this. So now I'm going to make a z-score for 28. Where'd it go? 29.3. Divided by the correct spread. Before I would have used this, right? When I was talking about individuals, like every problem before today was all about one person, one thing. Now I got a group of things. That's what changes, is the spread.
So to be able to distinguish it from the previous problems, it would be the X bar?
That's one thing. That's one thing. I love it. So the question is about a mean of things. That must mean I took a sample. So when I take a sample and I ask about the sample mean, that's the two things that tells me to do that. And what do you get for the z-score? Negative.
Negative 1.94.
194. Yeah, I like it. All right, and then what do I do next to answer this question?
You go to the chart.
Yeah, go to the chart. I got a z-score now. Why do I know this is normal, by the way? This is a huge thing I totally forgot to make a big deal out of. Why do I know I can use the chart?
Because it's out of 30 minus 30.
Because n is greater than 30. So therefore, I know that the groups will now line up in a close enough to normal distribution. Close enough for what, Jeff? To use the chart. It kind of makes sense that a big part of this class, as we go through it, is going to be, when can I use this? Because these are answers that I want to use. When can I use this if it's normal enough? How do I know it's normal enough? Here's our first test to see if it's normal enough. Yes?
You said 30. You said n has to be
Greater than 30.
30.
So in this case, n was 39, greater than 30, normally no. You can do it, Jeff.
So when was it not normal?
If I would have. Alright. I didn't want to do this to you right now, and I pretty much never do this because it would be a little evil if you didn't notice it and you did all this work you shouldn't have done. But if I would have said this, if I would have said given the mean is this and sigma is this, find the probability that x is greater than 28 or what, or less than 20, doesn't matter. I can make a z-score, but can I use the chart? What's the only time I'm going to use the chart?
Always. It's
If
greater
it's
than
normal.
30.
Does this problem say shit about normality? No. Does it have a sample size? No, I'm picking one person, right? It's not x bar, it's just x. I didn't take a sample. Or what if I would have done this? Take a sample of 11. Can I use the chart? Can I use the chart?
No.
No, because it doesn't say it's normal, and does the sample size save its ass? No, it's not bigger than 30. So officially, if I gave you this problem, which I won't, but if I did, you would say, can't be done. If you think I gave you a problem like this, do it anyway because you're wrong. You missed something. Just do it. The book, I can't remember, the book is bad sometimes about saying it's normal. Or they say at the very beginning, they say all the problems below this are normal. So you got to remember that. They already said it. So if I would have said one thing, so right now you can't do shit with this. The official answer to this is, I don't freaking know. Stats 2, you start to learn how to deal with this. Right? But we don't teach Stats 2 here. Damn. I add one thing and you can do this whole problem easy. Normally distributed. Now you can do it. I don't care that n is 11. Do I need it to be bigger than 30? No, I already know it's normal. Right? In fact, how big was n on the problems we did before today? 1. Did that bother us? No, because every time I had to tell you it was normally distributed, right? So if I say it's normal, how big does the sample size have to be? It could be 1, anything. If I don't say it's normal, how big does the sample size have to be?
Greater than 30.
Greater than 30. That saves your ass. Okay, maybe. So why were we able to do this one? Because n was greater than 30. I like it. You don't. That's okay. So, on the back of this, I want you guys to do these. I love doing this. Notice how the first problem is all about how many people am I picking in the first problem? How many people am I picking in 1A? What's the first few words say? In 1A, what's it say?
Select a woman.
So I'm picking one person. Why am I able to do this problem then? Why? What do you look for to say that I can do this problem? Bone densities are known to be approximately normally distributed, so I don't need n greater than 30. I can do any n. Do you guys understand? I can do part A. Why? I said it was freaking normal. If I don't say it's normal, I better have a sample size bigger than 30, or I can't do it. All right, so try this out. Does anybody need a Z-score chart? You guys all have that? You're gonna need that bad boy. Okay.